I'm going to go over the material for chapter 7, where we're going to be learning about confidence intervals and sample sizes. So let's begin with lesson 7.1. On this lesson, we're going to learn about finding confidence intervals when the standard deviation is given to us for the population mean. So let's begin with some definitions. So the first definition that we're going to learn is that an interval estimate of a parameter is an interval or a range of values used to estimate the parameter. Now, this estimate may or may not contain the value of the parameter being estimated. So you're going to notice that in some of the problems, they're going to be asking us to find, like if a mean is within an interval. So that is what they consider the parameter. So maybe that parameter may or may not be on the interval, right? Now the next definition that we are given or that we have is that the confidence level of an interval estimate of a parameter is a probability that the interval estimate will contain the parameter. And then assuming that a large number of samples are selected. And that the estimation process on the same parameter is repeated. So this is basically the percentage of how confident are we going to be in regards of the parameter being within that interval that we're going to be finding, right? So that is a confidence level. And then we have the confidence interval. And basically, the confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample confidence level of the estimate. Now it's a lot of words, and this again, this is just the definitions. But again, let's go over what we have here. So we have an interval estimate of a parameter, and that is an interval or a range of values used to estimate the parameter. Again, when we are talking about parameter, we are given a value that a specific value depending on the situation, right, that we want to kind of like calculate and make sure, what how confident can we be of that value being existent, right, within the situation that or the situations that we can be given in statistics. So that's what the parameter is. Now we have the confidence level, and confidence level is how sure are we? What's the percentage of confidence that we have that this specific value will be in between the ranges or in between the intervals, right? That we have found out. So that is a confidence level. Confidence interval, it's those actual ranges. So it's the actual values from the problem where we are going to estimate for the parameter to be in there. So the confidence interval is the actual values on the range. Confidence level, it's how sure are we that this value, that this specific parameter will be in between this range. And then the interval estimate, it's just again the interval or the range of values used to estimate the parameter. Now on this lesson, we're going to focus on the confidence level and the confidence interval. Okay. Now, the next thing that I'm about to provide you is something that's super important. So please go ahead and write it down on a note of paper, because you're going to be using it for your homework, for the attendance assignment, and you're going to be able to refer back to it when we are working or when I'm showing you the examples. So there are 3 common confidence intervals. So there are 3 common confidence intervals. And those are the 90%, the 95%, and the 99%. Okay? Now, it is important that you realize that these are the 3 common confidence intervals that we're going to be using. I am not going to give you any problem where we have a different confidence interval. I'm only going to be giving you examples and exercises where you use 90, 95, and 99%. Now, this percentage is again coming from the confidence level. So the confidence interval, it's for these percentages of the confidence level. So that means that if we're finding the interval for a problem that says, for a 90% confidence interval, that means that whatever ranges we get, we're 90% sure that the parameter will be in between that interval. 95%, we're 95% sure that this parameter will be in between these intervals. 99%, we're almost 100% sure, right? So 99% sure that the value, the parameter will be in between these intervals. So that's what these 3 percentages mean, okay? So it's important that you recognize that we're always going to be working with 90, 95, and 99%. Now, from here, I'm going to go to the next section. So now I'll provide you the formula of how to find this confidence interval. So let me erase this. Oops, erase lesson 7.1. Okay. So we're still in lesson 7.1. So now comes the formula. So to find the confidence interval of the mean. So again, this is of a population mean, right? And something else is this is when the standard deviation is known. So the population standard deviation, okay? So the big formula that we're gonna have for this is we're gonna have our x value minus z alpha over 2. Now this is gonna look a little bit weird because it's full of symbols, but I'm gonna explain to you what all of them represent. So this is a formula for the confidence interval. So pretty much what we have here is that x will be representing the sample mean. So again, we're finding the confidence interval for the population mean. So we're going to be using the sample mean for x. So I'm going to go ahead and write them here on the side. So x is the sample mean. This little like an O symbol that is on the fraction on the top is the standard deviation. So again, for the population. N is the sample size. And then again, you want to take notes of this next part. Go ahead and write, if you have a post-it little card, go ahead and write it there. I'm going to go over these z-scores values, so the z values. Basically, we have our confidence interval, which affects the z values that we have here on the formula. So our z alpha over 2 equals 1.65 when the confidence interval, so I'm going to put CI, confidence interval is 90%. Now z will be 1.96 when the confidence interval is 95%. And z equals 2.58 when the confidence interval is 99%. So those z values are already given to you. I'm already giving them to you. You want to have them next to you whenever you're working on any exercises, so you don't have to go to the back of the book and then try to figure out what is the z value with the given confidence interval. We already know that z will be 1.65 if it says that it's a 90%, z will be 1.96 if it's a 95%, and z will be 2.58 if it is a 99%. Okay, so this is the big formula that we're going to be using for the confidence interval of a population mean. So this is basically when we have an x value, so a mean for the sample, for a sample mean, and we're gonna be using this, right, to know if the parameter is between this confidence interval. And again, this is a population mean, right? It's a confidence interval for the population mean. So that is a big formula that we're gonna be using over and over again for lesson 7.1. Now, there's another definition that I want to talk about, and this is the margin of error. So all of these problems that we have here basically are referring to whenever, let's say, there's a company, right, and a warehouse, let's say, and they make cereal boxes. Now maybe the size of the cereal box, right? The height has to be, I don't know, let's say 6 inches. Let's just say 6 inches, right? And sometimes, right, because it's not always going to be perfectly done. Maybe we're going to have some boxes that are, instead of 6 inches, they're going to be 6.5 inches, or other boxes will end up being 5.7 inches, right? So this is the margin of error. The margin of error is that measurement that tells us, like how far can we go from the actual size that we need, right? So how far can we go in that case from 6 inches for the height of the cereal boxes? So this is what the margin of error is. Now what I'm going to do right now is I'm going to give you the actual definition. So the margin of error also called the maximum error of the estimate is the maximum likely difference between the point estimate of a parameter and the actual value of the parameter. So again, this is like the maximum amount, of error that we can get away from the actual value that we're considering. Again, I'm going to go back to that example with the cereal boxes, right? Let's say our parameter is 6 inches. Well, let's say that the maximum error that the machine can do is of 0.5 inches. That means that the lowest value that we can have for the height is 5.5, and the maximum value is 6.5. So there we are noticing that we have some sort of range or interval, right, going from 5.5 to 6.5. So that is basically the margin of error. It's pretty much how off can a value be from the actual parameter that we're estimating. And in our formula, the value of z alpha over 2 times the standard deviation over square root of n equals the margin of error. So that is what represents the margin of error. Okay. So again, our x bar represents the sample mean. We're adding and subtracting the margin of error to find our new intervals. Okay. Now there's two assumptions that we can make for the confidence interval for a mean. So there are two assumptions. That are made for to find the confidence interval for a population mean. And again, this is when the standard deviation is given or is known. Now, these two assumptions are, first, the sample must be a random sample. that is the first assumption. And the second one is that either our sample size is greater or equal to 30, or the population is normally distributed when the sample size is less than 30. Okay, so it's those two rules, or those two assumptions, right? First, sample has to be a random sample, and two, either our sample size is greater or equal to 30, or the population is going to be normally distributed when and it's less than 30, or when the sample size is less than 30. What does that mean? On the problem, they are going to give us, well, this is not a normally distributed, population. However, the sample size is 50, or the sample size is 130, or, a number that is greater than 30. Or they're going to say we're working with a normally distributed population, and our sample size is 25. In that case, we can assume that we can go ahead and find the confidence interval for the population mean. But these two assumptions have to be made. Okay, now let's go over a couple of examples for this. I'm going to go ahead and erase this. So all of these definitions and properties are going to be part of your attendance assignment. Okay, so here, okay, so let's go over the first example. So this one's kind of a little bit long for the the wording, but it says a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo, and it says a random sample. So there is the first assumption, right? Of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population, standard deviation, to be 6.0 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. Okay, So there's this problem. A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. A random sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation to be 6 days. Find the best point estimate of the population mean and then 95% confidence interval of the population mean. So what I'm going to do, I'm going to go ahead and focus on the confidence interval of the population mean. Now, what are the steps? Well, for step 1, the first thing that you want to do is you want to know what is given. What information is given to us? I'm noticing that we have a random sample of 50 cards. That means that n equals 50, right? So this is a sample size. Then I'm also seeing that it says it had a mean time on the dealer's lot of 54 days. That means our x bar, which is the sample mean, is 54. Then they are giving us a population standard deviation, which is 6.0. And again, that's for population standard deviation. And they are also telling us that the confidence interval is 95%, which means that our z-value from the previous numbers that I gave you, it's 1.96. Okay. So now we're going to go to step 2. And for step 2, all we have to do is plug in values into the formula. Okay. So our formula for the confidence interval of a population mean is x minus z alpha 2 and then standard deviation over square root of n less than mu. Mu, again, this is mu and that's the population mean, right? And then sample mean plus z alpha over 2 times the standard deviation over the square root of n. Now, all of these values are given to us except for the population mean, right? So our sample mean is 54, so we're going to have 54 minus our z value is 1.96 times 6 over the square root of 50 less than mu less than, again, 54. Now instead of minus is plus 1.96 times the standard deviation, which is 6 over the square root of 50. So we are taking those values that we got from the problem, right? And we are plugging them into the formula. Now you're gonna have to use a calculator to multiply 1.96 times 6 over the square root of 50. And once you plug it in, you'll notice that you will get 54 minus 1.7 less than population mean less than 54 plus 1.7. If we simplify and subtract and add, we get 52.3 less than mu less than 55.7. Okay, that means that the interval between 52.3 and 55.7 days contains a population mean for a sample of 50 automobiles, and then this is with a 95% confidence interval. Okay, so it is between between 52.3 and 55.7 days, right? And that's when we have the population mean for a sample of 50 automobiles. And so this is with a 95% confidence interval. Okay, so that's the first example for this. Let's go ahead and go over another one. I'll go ahead and erase this. And let's go over the second example. Okay. So this one says a large department store found that it averages 362 customers per hour. Assume that the standard deviation. So notice how they are giving us what the standard deviation is, right? They're not asking us to find it. They're not like giving us the values to get to it, like the list of the mean. Actually, there are problems where they give you the list of the data and then you have to find the mean, variance, the standard deviation, but I'm not going to do that to you. I'm just going to give you, problems where the standard deviation is just given. It says in a random sample of 40 hours was used to determine the average Okay, so it says find the 99% confidence interval of the population mean. So again, they're asking us to find the confidence interval, right? So just like on the previous problem, the first thing that we want to do, so our step one, it's going to be to list down the given values. What is given? Well, from what I'm seeing, it says that a large department store found that it averages 362 customers per hour. Right, so, and then it says assume that the standard deviation is 29.6 and a random sample of 40 hours was used to determine the average customers per hour, right? So given my sample mean is 362 and then my sample size is 40 hours, my standard deviation is 29.6, and then my confidence interval is 99%, which means that my z value, and this is from the numbers that I gave you, it's 2.58. Okay, again, you don't have to find z. The z was given to you when I provided the formula. So for step 2, again, all we have to do is plug in the values into the formula. So my formula is sample mean minus z alpha 2 times standard deviation over square root of n less than mu less than x plus z alpha over 2 times standard deviation over square root of n. And now what we're going to do is we're going to go ahead and plug in values. So we have 362 minus 258 times 29.6 over the square root of 40 less than mu less than 362 minus 2.58 times 29.6 over the square root of 40, and that should be a plus. I don't know why I put a minus. Okay, so we have the minus and then we have the plus. Now again, we have to plug those in the calculator, and we get 362 minus 12.1 less than mu less than 362 plus 12.1. So this is going to give us 349.9 mu and then 374.1. So again, this is a population mean, right? Now, because we're talking about customers, we're not going to have decimal values. So all we're going to do is we're going to go ahead and round. So 349.9 is going to round up to 350 mu and then 374. So that means that the average, population mean, or the population mean for the customers per hour is between 350 and 374 customers per hour. Okay, so we can be 99% confident that the mean number of customers that the store averages is between 350 and 374 customers per hour. And we're done with finding a confidence interval for a problem where the population standard deviation is given to us.